Hello friends, this video on Chemical Kinetics part 11 is brought to you by examfear.com. No more fear from exam. So now the chemists were confused. Why? Why this is my equation? In the rate law, x and y has to be found experimentally. Why a and b are not used? They were confused. They were happy with this rate law because they were able to solve questions. The theoretical value and the experimental values were coming out, they were matching. But they were confused. Why? Why this is not matching? Have you ever thought why this x and y has to be determined experimentally? Why it is not matching with a and b? You thought a lot. And one of the chemists came up with the idea. He thought, okay, let's see the reaction mechanism and let's see what happens there. Correct? So when the chemists saw the reaction mechanism, they saw that generally in a reaction, 1 or 2 or 3 molecules of the reactant combine and they boom, bang, and they form a product. Correct? Molecules combine, they bang, and they form a product. Also, they found that the balanced equation never gives a true picture of how the reaction happens. This is the reaction and this is a balanced reaction. Looking at this, it looks like 6 plus 3 plus 1. 10 molecules are reacting with each other to form the product. But this balanced reaction is not giving a true picture. Something is hidden behind this mask. The balanced reaction will never give a true picture. Why? Because mostly the balanced reaction which we see, they are not in one step. They are in multi-steps. Right? So we have this term called elementary reaction. Reaction which take place in one step is called elementary reaction, and complex reaction which take place in more than one step. For example, this is a complex reaction. If you see this reaction mechanism of this reaction, it takes place in more than one steps. Just to understand why in the rate law the x and y were not matching with the coefficient of the reactants. So they found that most of the reaction we see is not an elementary reaction, they are complex reaction. They don't take place in one step. So they came up with a term called molecularity of a reaction. It's a very, very important concept. It will help you to understand the reaction mechanism, right? So it tells the number of reacting species taking part in an elementary reaction. Please note, it is number of reacting species in elementary reaction. So the moment you talk about the molecularity of a reaction, you talk about only elementary reaction. We are not talking about the complex reaction. Correct? Example, 3 molecules, boom, forms a product. So in this case, the molecularity is 3. Please note, once again, when you talk about the molecularity of reaction, you talk about only elementary reaction. We don't talk about complex reaction. But when we talk about the rate law, we don't care. It's a complex reaction, simple reaction. We don't care. Even when we solved all the questions of rate law, we were not even introduced with this term of complex reaction and the simple reactions. So rate law doesn't matter, but for the molecularity of the reaction, we will talk only about the elementary reaction. Correct? And in that elementary reaction, the number of species that take part, that will tell you the molecularity of a reaction. Typically, we have unimolecular, bimolecular and trimolecular reactions only. In unimolecular reaction, one reacting species is involved, only one reacting species. For example, you see, this is the one reacting species, it bombs on its own and you get product. For example, decomposition of ammonium nitrite, NH4, NO2, it will decompose into N2 and 2H2. Or radioactive decay also we can say. These are all, please note, these are all what? they are not complex reaction. They are elementary reaction. Once again, molecularity of the reaction, this term is applicable only for elementary reactions. So the first one was the unimolecular reaction, where you have only one species involved in the reactant. The next is bimolecular. It involves collision between two species A and B. They collide, bond, and they get a product. For example, dissociation of hydrogen iodide. I have 2HI. It will give me H2 plus, or CO plus NO3 gives NO2 plus CO. These are the examples of a bimolecular reaction. Please note these again. These two are my simple reactions. They are not complex reactions, right? They are my simple reaction, or we call elementary reaction. The next is trimolecular reaction. Here the collision between three reacting species take place. Example, if you see, 3 comes, react, bond, and get a product. For example, 2NO and oxygen react to form NO2. This is an example of trimolecular reaction. Please note, these reactions are only for simple reactions. Molecularity concept itself is for simple reactions. The probability that more than 3 molecules combine is very less, and therefore molecularity greater than 3 is not observed. Please note, molecularity greater than 3 is not observed. So we talk about this complex reaction. For example, this complex reaction I have. So this must be taking in more than one steps. These are multi-steps. Each step will be a simple reaction. Correct? And molecularity term itself is only for simple or elementary reaction. So if you want to find the molecularity of this, find all the steps, and for each steps you'll have molecularity actually, right? And then the slowest step will give you the order. We will explain that. Just understand this term now. Molecularity of the reaction is only 3: unimolecular, bimolecular, trimolecular. Why? Because it is observed that more than 3 molecules, they never combine to form product in one step. If this is the reaction we are seeing, we have 6 plus 7 plus 3, 10 molecules are combining. That means they are not combining in one step. They are combining in multiple steps, right? Because this reaction seems to be of 10th order, but actually this is second order reaction. Experimentally it is seen it is second order reaction. And why it is second order? The molecularity will give you the answer for this. Correct? Now, since I told this is a multi-step, it will have so many steps. But there has to be a step which will control the rate of the reaction. Obviously, slow step. The weakest link is determines the strength of a chain. The slowest step will determine the rate of the reaction. For example, a big crowd is leaving a theater, and they are leaving the theater after a movie, and they are all leaving through a very small narrow exit door. So the time for the crowd to leave the whole building is nothing but the time for the crowd to pass through that narrow road or narrow door. Same thing. So the rate of this rate of this reaction, if it has, let's suppose, 6 steps, right? The slowest step, let's suppose slowest step, the rate of the slowest step is nothing but the rate of reaction. The weakest link in the chain determine the strength of the chain. And same thing as I told, the example of the crowd leaving a cinema hall. Or traffic also, if you're passing through, there is a narrow passage. So the time it takes for the cars to move from city A to B, let's suppose there is a city A and there is a city B. There is a distance of, let's suppose, 100 kilometers. But let's suppose there is a small narrow passage here and only one car can go, right? But so let's suppose the car can drive at 100 kilometers per hour in this highway. So if the distance is 100 kilometer, the expected time for a car to reach A to B is 1 hour. But there is a small passage here. All the vehicles are blocked here. All the vehicles are blocked here. Right? So the speed is very, very less. So it will take more time for this car A to go to B, and this small passage will actually determine the overall rate. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.